All right, forwards and onwards, we are going to look at looping over a slice. A slice is a list. Here I've created a slice of friends. We already saw this. I put in different friends' names this time, but I say, I give it this bracket notation and then the type, right? So is it going to be an int? Is it going to be a string, float 64, or even more different? There's different kinds of types we could create a slice of. And then I just put in my values, right? So there are my values into the slice. One thing, if you're ever looking at code and you see something like this, right, or some numbers in there, that is an array. It is not a slice. In Go, we use slices. Slices are like dynamic arrays. A slice can grow and shrink in size. And we'll learn more about sort of like, the internals of how slices are created. But that's all you need to know right this moment is slices can automatically grow and shrink in size, while arrays are of a fixed size. They don't dynamically grow and shrink in size. So we use slices, and slices are built on top of arrays. And we'll learn more about the internals of slices in just a minute. So anyhow, we're looping over a slice. I've got my slice. Now I've got my loop, I've got my initialization, I've got my condition, and I've got my post. And I'm saying while I is less than or equal to 3, because I have 0, 1, 2, 3 are my index positions, right? I've got those index positions. So now I could format print line, and I could access friends just like I did before, when I print line friend, show me the position 0, which would give me Mike, or show me the position 2, which would give me Trevor. I could say show me a position I. First time through the loop, this will be 0. Second time through the loop, this will be 1. Third time through the loop, this will be 2. Fourth time through the loop, this will be 3. Did I say that right? I didn't say that right. First time through. So, first time through is 0. So I did say that correctly. Anyhow, it just sounds weird, right? Because it's always like one-off. That's even a very common programming mistake. They call it a one-off error. All right, so that's how we do it. When we run this, we can see the output down here. I got Mike, Cy, Trevor, Greg. What would have happened if I just put this to 2? I just get, through index position 2, Mike, Cy, Trevor. What if I'd started at 1, right? I would just get Cy and Trevor, right? And so that's actually pretty interesting right there. And that gets us, starts to bring us up to this idea that, we could just get a portion of a slice and bring it out. One thing I would change about this, if I was, this is production code or whatever, I would add in this line right here. And that line, I'm a fast typer, aren't I? I'd already copied that. That line right here gives me the length of friends. And so when I run this, I can see the length of friends is 4. So I'm going to move this back to 0. I'm going to move this one back to 3. Right? 3. And I'm going to run it. And Mike, Cy, Trevor, Greg. Well, what about if I had less than 4? That's the same thing as less than or equal to 3, right? They're going up through 3. If I run this, same thing. Well, instead of putting in 4 right there, I could have length of friends. Copy that and put that right there, length of friends. And now I could run it, and same deal, right? So I just want to show you sort of what that length deal does right there. And so it gives me the length of this slice, how many items are in it. And then I could use that in my loop as my, not my init, not my post, but as my condition right there. So that's pretty cool. That's looping over a slice. We could also print out what's in a slice by doing it this way. And this will just print out the entire slice, and we'll just kind of get that right there. And let me format that and run that. And so that, waiting for remote server, gave me this slice. And what I want to show you is we were accessing things by index position. So that's accessing something by index. It's going to give me Cy, right? But I could also do something like this. I could do, 1 and then colon. When you see that colon, we are now slicing a slice. And so that's going to say from this position forward all the way to the end, right? And that'll give me Cy, Trevor, and Greg, right? But it's giving me still, you can see I've got brackets around there saying, here's your slice. You sliced that slice, and that's what you get. I could slice up through something. So if I did this notation up through 2, this will be like everything up to, but not including index position 2. So 0, 1, 2, it's just going to give me Mike and Cy. And you're like, what? Why does that work that way? because, and you can see there, Mike and Cy. The reason it works that way is it's kind of like in math or whatever. That's just the way it works. I don't know why it works that way. But in math, it's like this notation, you know, where they have everything but not including, right? They use that math notation in math, I think, if you remember that. And maybe I don't. It's been a while since I've done that in math. So anyhow, that's slicing a slice. If I wanted to see just Cy and Trevor, I would put in from position 1. It includes position 1. And I want to go all the way up through position 3 because it does not include position 3. 0, 1, 2, 3 does not include that. So that just give me Cy and Trevor. So that's slicing a slice. So printing a slice, right? Looping over slice, printing each element. We saw that. We saw printing the whole slice, just, you know, print the whole thing and let me see it in slice notation. We saw that. Slicing a slice, we saw that. And the next thing that you need to know about with slices is slices are built on top of arrays. And so slices have an underlying array. A slice is a reference type. So if you have some programming experience, a reference type, its header is pointing to, right? Its header consists of three words. The first one is a pointer to the underlying array. The second one is the length. The third one is capacity. And if you look up the documentation on slices, so if we go to like, you know, this is the Golang spec right there. And if we look at slices, right, it tells us some stuff. But then we see here we've got make, slice of int, 50, 100. Well, this is saying make it and give it a length of 50 and a capacity of 100 because the underlying array is now made to size 100. Arrays are of a fixed size, right? And so we're starting out with just, you know, 50, the length of 50. If we keep adding things, we still get to continue pointing to that same underlying array. And if we add item 101 to our slice, we then get a whole brand new array. So the computer has to, you know, create a whole new array. And that has a little bit of a cost. And so you want to think about, you know, if you are going to be, you know, using a slice, you know, and you're in a certain situation, you want to think about your length and your capacity. And so just as an illustration of that, let me open up a piece of code. So this is a cool thing about github.com. So I've gone to one of my repositories and I could search this repository, and I searched this repository for make, as in making a slice. And so I could see all the places where I'm using make. And so here I'm making, you know, a slice, and the one I'm looking for is like, you know, right here, I'm going to make a slice. That slice is called row hex. It's storing strings, and my length is originally going to be 0, and my capacity is going to be the bounds on an image, right? Like, so, you know, the number of pixels left to right of the x, left to right, the x, the number of pixels, so the width of the image in pixels, because I'm going to store information about each pixel in that slice. And so I'm going to create the array the perfect size to hold everything without the array having to be recreated. If I didn't do it this way, I'd be recreating arrays over and over and over and over again, and that would have a bit of a performance cost. And when I'm dealing with, like, you know, millions of pixels, that's something I want to think about. So that's make. Let me see if there's anything else I want to say about slice. All right, so don't get too hung up right now on, you know, all the details of right, you know, like all of that theory stuff. That stuff will come in time. I think it's fun just to get in there first of all and start cutting and gluing and hammering and nailing and working with the stuff. But one thing to know is that make is used for slices, maps, and channels, and I highlighted that here in the effective Go. And the reason is because slices, maps, and channels all have some setup that needs to be done underneath the surface. So slice has an underlying array, right? And so that's why we use make with that. And so we could pass in some arguments. How do you want it made, right? And so that's make. What else? Anything else? Say, oh, we have a challenge. And so the last thing I want you to do for a challenge is I want you to create a slice, and I want you to store, you know, some of your favorite food items, and then I want you to loop over that slice and print out each item. And then I also want you to print the whole slice, just like with the bracket notation. And then I want you to slice that slice and print out a portion of it. So do that. Pause this video, go do that, and then I'm going to show you the solution. All right? Okay, so here's the solution. So food, I'm just going to call it food, and then it'll be like what, ice cream, and I don't know why these are still just some of my standby favorites, and I don't know, coffee. I'm going to be needing that pretty soon. And then so I want to slice my food. There it is, and I could run that just to make sure that all runs. And I didn't have that right next to each other. It should be though. There we go. So that went from 0, 1, 2, 3, gave me those two. And then I want to loop over it. So I'm going to do for I colon equals 0, semicolon, I is less than length of food, right? And I plus plus. And then dot, 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 dot. And then we're going to do format.println. And we're going to do food, and then give me position, whatever position we're at. And then after that, there's something else we want to do, slice. I just want to print the whole deal. And we're just going to print food. I think that should be right. I might have made an error. Aha! Okay, so all worked well. That was your challenge. I hope you nailed it. And the more you work with this stuff, the more you're going to get it.